Why can you feel a shock before you even touch a doorknob? Why does lightning jump through the air to reach the ground? And how can a tiny battery push electrons through an entire circuit? To understand all of that, you need two ideas: electric field and electric potential. Take a small scrap of paper and bring a charged balloon close to it. The paper moves without being touched. Something invisible is reaching out and pulling it. That something is an electric field. An electric field is simply the influence region around a charge. If a charge is nearby, you feel its push or pull. If it's far away, the effect gets weaker. We draw this influence with field lines, arrows showing the direction a positive charge would move. Outgoing lines, positive charge. Incoming lines, negative charge. Closer lines, stronger field. Spread out lines, weaker field. Nothing fancy, just a map of how a charge affects space. Now, electric potential is the next idea students confuse, but it's simple. Think of it like height in a gravitational field. High place, high potential energy. Low place, low potential energy. Objects naturally roll down from high to low. Electric potential works the same way. High potential, low potential. Charged particles roll from higher electric potential to lower electric potential. The difference between 2 points is called the potential difference, or voltage. Voltage doesn't mean how many charges you have. Voltage means how badly charges want to move. A battery doesn't push electrons because it has many electrons. It pushes them because it creates a difference in potential, like putting a ball on a hill. The ball rolls because nature prefers lower energy. Electrons move because nature prefers lower electric potential. That's why circuits work. Electrons flow from low energy to high energy regions, controlled by the electric field inside the wires. Lightning is the same story. A gigantic potential difference between clouds and the ground. When the difference becomes too large, the electric field becomes strong enough to tear electrons out of the air, creating a sudden discharge. And here's the hidden link students often miss. The electric field is what causes the movement. The electric potential tells you where things want to move. Field equals the push, potential equals the landscape. Voltage equals the height difference. Electrons just follow the path downhill. Now think about this. If electric fields and potentials control how charges move, what happens when charges start moving in loops? How do wires, coils, magnets, and motors suddenly become connected? That takes us directly to capacitance, current electricity, and magnetism. And we'll unfold that in the next lessons.